Welcome to the ET302 parallel resistor calculations and the TI-30XIIS calculation operation video. Here I'm showing the TI-30XIIS calculator. It's very reasonably cost. It's the one we recommend, and it's very easy for students to use in our electronics courses. The first thing we need to do is turn it on. Here's the on button. To turn it off, we need to do a second. Use our blue button here, second off. So the white ones on top are the primary key, and the secondary key will be pressing the second button and then doing the blue function. Okay, so first thing we want to do is set up our calculator to do engineering notation. So we're going to push our second key, our science engineering key, and then use our arrows in order to select the engineering mode. That's what we're going to use in electronics, is basically factors of times 10 to the 3. So that's the best way to do it, and you don't have to move decimal points or things like that. It's going to come up with our answer right away. Okay. And we have our enter key that we need to press anytime we do a calculation. We have our standard multiplication and addition keys. And we have, when we do exponents, we're going to put our number in, and we have to push our second key, and then we're going to use our EE button. All right, and that's going to give us our exponent, 10 to some certain power. Okay, and if it is a minus exponent, like 10 to the minus 3, we're going to utilize this key here. This is going to modify our exponent. Do not use the subtract key, it's wrong. Okay, and anytime that we need to do an inverse, here's our inverse key. And that will do 1 over whatever the number is to inverse it. So we're going to use this a lot. Some of these keys may be x, 1 over x, and that's a similar kind of key. But our calculator is going to use x to the minus 1. Okay, we've already covered series resistors, or basically just adding up the total resistance. So it's just summing up our resistors. Our parallel resistance formulas are going to be a little different. If you look back at our series, it was just R total. What we use is R equivalent, meaning that we're going to use a more complicated formula. With our scientific calculators, this is not such a difficult calculation. Here's our first example of parallel resistors. We have a 3 ohm and a 4 ohm, and you notice they're in parallel. And I put the numbers into our formula. Here I'm showing the keypad of our calculator, and I'm going to show you how to do the parallel resistor example. And we're going to push the 3 key, inverse key, x to the minus 1, plus 4, inverse x to the minus 1, enter, we're going to do inverse again, and then enter, and we're going to come up with 1.7 ohms. Okay, there's a simple parallel resistor rule that the equivalent resistance will always be less than the smallest resistor. So this could be used as a check. Well, if you calculate it, and it should be smaller than the smallest resistor. This is also helpful in multiple choice tests, including the FCC exams. It'll save you some time. So the equivalent resistance will always be less than the smallest resistor. Here's our parallel resistor example 2, and this time I'm using a multiplier. These are K ohms, which is 1,000 ohms. And again, I put it in the formula. So a K is equal to 10 to the power of 3. Okay, so let's go ahead and use our calculator. Here's our calculator keyboard, and what I'm going to show you is how to use our EE key so we could do powers. If we use this key, it's going to simplify the equations. We don't need to move decimal points or anything else. It's all done for us. All right, let's get started. So we have 5 second EE 3 inverse. So what we have here is 5k. So 5 times 10 to the 3. All right. Then we're going to add 7 second EE 3 being k. We're going to inverse it. We're going to push the enter key, inverse it again, and then push the enter key, and we're going to come up with 2.9 k ohms. And again, this resistance is smaller than either two of our parallel resistors. So this is going to allow us to do exponents. So if it's k, it's going to be 3. If it's meg, it's going to be 6. If it's milli, it's going to be minus 3. It's going to be minus, and then 3. And micro is going to be minus 6. Here I have another simplification rule, the parallel resistor rule of multiple equivalent resistors. So anytime that we have equivalent resistors, and they must be equivalent, is we could use that resistance and divide it by the total number of resistors. Here we have 2.6 ohms. We have 2 resistors, so we're going to have a equivalent resistor of 3 ohms. Here's another rule, same rule, but with just another example. And we have 3.6 ohms. And 6 ohms divided by 3 is going to be 2 ohms, so our equivalent resistance is going to be 2 ohms. So these parallel rules that I've shown will help you in solving these, but it'll also shorten the time of doing troubleshooting, because many times in troubleshooting we just need to get a ballpark idea of what the resistance is so we could continue with our troubleshooting. So we could use our smallest rule, and we could use these multiple parallel resistor rules in order to do troubleshooting and to simplify our analysis.